Hello, welcome to Prajim Technologies. I am Venkat. This is part 7, data type conversions in C#. In this session, we will learn implicit conversions, explicit conversions, and the difference between parse and try-parse methods. Let's look at an example. Let's say I have a variable of type integer which is initialized to a value of 100. Now, I want to convert this to float data type. So let's say I have a variable of type float and I want to initialize this variable with the value of this variable. So I will say float f equal to I, and then I want to print the value of this float variable. So now if I go ahead and run that, integer is initialized to 100, the value of integer is assigned to float, and the float value is printed, which is 100. So the conversion happened without we having to do any explicit conversion. So what are we doing here? We are converting an integer to a float data type. From the previous video sessions, we know that float is a much bigger data type than integer. So obviously, when we convert integer data type to a float data type, there is going to be no loss of information, number one. And number two, there isn't going to be any exception as well, because integer is much smaller than float data type. Okay, so implicit conversion, when does that happen? Implicit conversion is done by the compiler for us automatically when there is no loss of information if that conversion is done. So obviously when we convert from integer to float, there is going to be no loss of information, and if there is no possibility of throwing any exceptions during that conversion. Okay, because float is a much bigger data type than integer, so there is no possibility of overflow exception happening. So that's why the conversion happens for us implicitly without we having to do it. Okay, so let's think about this the other way around. Let's say I have a variable of type float which is initialized to 123.45, and since it is a float variable, I have to suffix letter f. Now I have another variable of type integer I, and I want to initialize this with a float value. So if I do this, look at the red squiggly line under that f cannot implicitly convert type float to int, because we know that float is a much larger data type than integer, number one. So there is a possibility of overflow exception if the number is much bigger. But in our example here, the number is 123.45. So integer can hold 123. In fact, it can hold a much bigger number. So there isn't going to be an overflow exception, but there is going to be loss of information. In what form? Float can have fractional part, but integers cannot have fractional part. So now if we actually try and print this integer, have a look at what's going to happen. It doesn't give us any exception. Sorry, but we have to do that conversion here because compiler will not do the conversion for us. And there are two ways to do the conversion. That's the explicit conversion. Because look at this, integer cannot hold fractional values. So if the compiler were to do this conversion, what would have happened? We would have lost that fractional part. And if this is a measurement of some, engineering calculation or a chemical formula or any financial value, it would have a great impact on the business. That's why the compiler, if there is going to be any loss of information or if there's going to be an exception, it will not do the conversion for us. We have to do that explicitly. Okay, and how do we do it explicitly? There are basically two ways. One is you can use the typecast operator, which is an opening and a closing parenthesis, and the other way is we can use the .NET Framework's convert class. So let's go ahead and use the typecast operator. So I want to convert this variable to be of type integer. Now if I go ahead and run, look at this. The actual value of this float variable is 123.45. But since we have converted that to an integer, we have lost that fractional part. So that's why the C# compiler didn't do this conversion implicitly for us, because there is a loss of information here. So obviously, the general rule is that if you're converting from a smaller data type to a bigger data type, the conversion happens for us implicitly. But on the other hand, if we try to convert a bigger data type to a smaller data type, because there is a possibility of overflow exceptions, number one, and there is possibility of loss of information, that's why the compiler will not do the implicit conversions for us, and we have to do the explicit conversions. And one way to do the explicit conversions is to use the typecast operators as shown here, and the other way is to use the convert class. For example, I can do the same thing using the convert class, convert dot to int. Now you will see different versions of toInt methods here: toInt 16, 32, 64. Now what are these? Depending on the the size of the integer data type that you are using, in 16 or in 32 or in 64. In 64, obviously we have 64 bits there, meaning 8 bytes. It can hold a much bigger number. Okay, but anyhow, let's use 2 and 32. And if I go ahead and run this, there's not going to be any difference in the output, except that we are using the convert class. So within the convert class, there are actually several methods. If you want to convert to decimal, you can do that. If you want to convert to date time, you can do that. To char, to billion. So from any data type to any data type, if you want to convert, you can make use of this convert class. That's another way that we have to do the explicit conversions. Now, what is the difference between using typecast operator and using the convert class? If I use the typecast operator, and if this float is going to hold a bigger number than an integer, obviously if you look at this number, this is much bigger than an integer variable can hold. So if I run this, and if I try to convert this float to an integer, there will actually be an exception, because an integer variable cannot hold this huge number. But look at what's going to happen. So when I run this, actually I think it can hold that number. Let's make this slightly bigger. Yeah. So now if you look at this one, we got a number saying -2. This is the least, the minimum number of an integer. Okay. The interesting thing to notice here is that the typecast operator did not throw an exception. It tried to do that conversion from float to integer, but it failed, and it is just showing the minimum number that it can hold. So if we use the typecast operator, we don't get an exception. But on the other hand, if we try to do the same thing using the convert class, we get the exception. So when I use the convert class, so convert dot toInt 32, if I run this, I get an exception, unhandled exception, system.overflow exception. Obviously, this value, when I'm trying to hold that in this variable of type integer, it cannot hold it. It's much bigger. So obviously, overflow exception occurs. Okay, so there are two ways to do explicit conversion. One is to use the typecast operator, the opening and closing parentheses, and the other one is to use the convert class. The difference between them is that we use the typecast operator, we don't get an exception, whereas with the convert class we get exceptions, if at all there is an exception. So we have seen the implicit and explicit conversions. So this is an example of an implicit conversion example, which we have already seen, and an example for explicit conversion as well. And as I told you, there are two ways to do it, using the typecast operator and the convert class. Difference: typecast operator doesn't throw an exception if there is a problem converting that data type, whereas convert class does throw an exception. And finally, there is another way to actually convert between data types. For example, let's say the number that I have is in a string format. For example, str number equals 100. So basically, this is a number. We know that as humans, but then since that is, enclosed within double quotes, it is treated as a string by the C# compiler. So because of that, if I try to do this, int I is equal to str number, if I try to do this, the compiler will throw an error saying that cannot implicitly convert between types, string and integer. Okay, so obviously we got to do the explicit conversion, and and if the number is in a string format, there is a better way of doing this using the parse method. So we want to convert this to integer. So int dot parse function, and you call that, look at the data type. It expects, a string to be passed in our case str number, and it will convert that string to an integer. So obviously, if you look at the return type from the IntelliSense, the return type of the parse method is integer, and it will store that in this variable. So obviously, when we try to print that, console.writeLine I, it prints that. Okay, very good. A third way to convert from one data type to another, especially if that data type is in a string format. Okay, now let's say, for example, by mistake, I have some digits here, some characters from alphabets. Okay, now is this a valid number? Definitely not. Now if I go ahead and try to run this application now, when the application runs, it tries to convert this number to an integer, and obviously it cannot do that, and there will be a format exception. So the format of this number cannot be converted to an integer, so we get an exception. So let's run that and format exception as expected. Okay, now how do we avoid these exceptions? There is a variation of parse method which is nothing but a try parse method. Okay, so let's say, for example, I want to convert this to an integer. I can use, instead of parse, there is a try parse method, and if you look at the parameters for this method, they are slightly different. It takes a string input which we want to convert to integer data type, in our case str number, and then the other output is an output parameter. After this method converts this to an integer, where should it store that value? Into the parameter that we are going to pass right here. Okay, so first let's create a variable to hold the result. So int, let's say result, and let's initialize that to 0, and now we pass this variable as a second parameter. So now what's going to happen? Okay, another important thing, you have to use the out keyword. I'll tell you why in just a bit. Okay, so this try parse method is going to take the string, convert it to integer, and store it in this variable, and this is an output parameter for this method. Now functions can have different types of parameters: value parameters, reference parameters, output parameters, and parameter arrays, which we'll be talking about in a very great detail in a later session. So until then, don't worry about that. But what's happening here is this try parse method converts the string into an integer and stores in this variable. But here, look at this. The string cannot be converted to an integer. So what will happen to this? This will remain 0. And another interesting thing to note is that the return type of try parse method is actually Boolean. So what does that mean? The try parse method will return true if the conversion is successful, otherwise it will return false. So there is a Boolean return data type that's coming back. If the conversion is successful, it returns true, otherwise false. So we can say bool is conversion successful. Now if this conversion is successful, then this method will return true. So what we can do is, if conversion is successful, then we know that there will be an integer number that we can print, else we can say console.writeLine, please enter a valid number. Okay, so if we go ahead and run this, what's going to happen, since this number cannot be converted into an integer, it throws in, it doesn't throw an exception, but this try parse method will return false. And since this is false, it gets to the else block and it will ask us to enter a valid number. On the other hand, if we enter a valid number, something like 99987, and run this program again, it prints that valid number. Okay, so that's basically the difference between parse and try parse. So let's go back to the slides. So if the number is in a string format, you have two options basically to convert that from string to any other data type, maybe integer, float, double, whatever. Okay, parse and try parse. Parse method throws an exception if it cannot parse the value, whereas try parse returns a boolean indicating whether it is succeeded or failed. True if successful, false if fail, but it doesn't throw an exception. So in general, use parse if you're sure that the value will be valid and there's not going to be any exception. Otherwise, use try parse in case of any doubt. That's it for today. Thank you for watching. Have a great day. Hello, welcome to Prajim Technologies. I'm Venkat. This is part 8, Arrays in C#. In this session, we will learn what arrays are and the advantages and disadvantages of using arrays. Let's look at an example. Now, if I create a variable of type integer, I can only store one value within that. If I want to store more than one value in this variable, it's not possible. That's when arrays come into picture. If you want to store a group of similar data types in a single variable, you can make use of arrays. For example, let's say I want to store a collection of even numbers. To do that, I can create an integer array and store my even numbers. Let's see how to create an array. Let's say, for example, I want to store 3 even numbers, and obviously even numbers are integers. So I can create an integer array whose size is 3 and store 3 integers within that. So let's see how to create an integer array. Now, to create a variable of type integer, we say this is the data type, this is the name of the variable, and this is the value that we want to assign to that variable. But on the other hand, if you want to create an integer array, you'll say int of square brackets. So these square brackets indicates that we are going to create an array. And let's give it a meaningful name. For example, we want to store even numbers, so I'm going to name that. And okay, so we know that we are going to create an integer array. This is the type, and this square bracket indicates it as an array. And if it's an array, we know that it's a group of similar data types. In this case, group of integers. How many integers do you want to store? 1, 2, 5, 10. So you have to specify the size. So to specify the size, you use the new keyword and say int, and then again within a square bracket, you specify the size of the array. In this case, I want to create an integer array and store 3 integers within that array. And how do I store these 3 numbers? Now, arrays are integer index based starting at 0. So the first element is at position 0. So even numbers of 0 equals 0 because the first even number is 0. Even numbers of 1, the second even number, which is 2. Similarly, even numbers of the third element is 4. And let's say, for example, I want to print the second even number, console.writeLine even numbers of 1. So what's going to happen, in this location we are storing 2, so it prints that number out when we run this program, which is nothing but 2. In position 1 we are storing 2 and we print that out. So this is a very simple example of an arrays. Okay, now what is the advantages of what is the advantage of using arrays? Obviously, an array is a collection of similar data types. So if you want to store a group of similar data types, then you can make use of arrays. It could be integers, floats, doubles, string, any data type for that matter. For example, if you want to store, you know, your friends' names, a group of friend names, then you can make use of a string array. All right. Now, what is the advantage of using arrays? The advantage is they're strongly typed. Okay, meaning if the array is of type integer, you can only store integers within that array. And if you try to store, for example, let's say accidentally, if you try to store maybe a string, for example, like hello, we know this is of type string, but this array is of type integer, and you already see there a red squiggly indicating an error. So cannot, if you look at the error message, it says cannot implicitly convert type string to int, because we know that even numbers is an array of type integer. Okay, so arrays are strongly typed. That's a very good benefit. Okay, we will realize the advantage of being, strongly typed later when we compare arrays with other collection classes that are available within .NET Framework, which are nothing but lists, and generics, etc. So until then, don't worry about that. Just keep in mind that, arrays are strongly typed in nature, which is definitely the greatest advantage of arrays. Okay, now what are the disadvantages of using arrays? The disadvantages are, once you initialize the size of an array, they cannot grow in size anymore. For example, in this case, the size of this array is 3. Now, if I try to hold a fourth element within this array, for example, 6. Now, if I go ahead and compile this, and the way to compile is go to the build menu, say build solution. And if you look in the status bar at the bottom left hand corner, it says build succeeded, so no issues. But on the other hand, when you actually run this at runtime, you get an exception. And obviously, you get an index out of range exception. Okay, so what does that mean? That means the array size is 3, but I'm trying to store a fourth element into that array, which is not possible. So we don't have a location 3, which is technically 4 because it starts from 0. So the index is out of range if you want to store a fourth element into this array. And that makes sense. Okay, so what does this prove? This proves that once you specify the size of an array, it's fixed. You cannot, store more elements than the initial size. So it means arrays cannot grow in size over time. That's one disadvantage of arrays. Actually, within .NET, we have other collection classes like list, hash table, etc., which can grow in size automatically, which we'll be talking about later when we talk about those collection classes. So until then, don't really worry about them. Okay, so one of the disadvantages of using arrays cannot grow in size once initialized. Another disadvantage, we have to rely on the integral indices. There is no better way to store or retrieve items from the array. But if we use collection classes, it's very easy to store or retrieve items. We don't have to rely on these integral indexes, which we'll be talking about when we actually talk about collection classes in .NET. Okay, but for now, understand that the only way that you have to store or retrieve elements out of an array is to rely on these integral indexers. For example, let's say by mistake, if I try to retrieve an element, maybe instead of typing 1, by mistake I typed 10, and when I go ahead and build the solution, it compiles fine, no compile time error. But when I try to run this program, it gives me an index out of range exception because this location does not exist within this array. And why did that error happen? Because I have to rely on these integral indexers. Okay, so that's why arrays are good in a way. They are strongly typed, so definitely that's the greatest advantage of arrays. Once you define an array to be of specific type, you can only store that specific type of elements in that array. That's a greatest advantage. But the disadvantages are, Once you define the size of an array, they cannot grow in size over time, number one. And number two, the only way to store or retrieve elements out of the array is to use the integral based indices, which is definitely error prone and a little complicated. But on the other hand, if we use the collection classes that are available in .NET Framework, they are type safe, number one, and also there are several convenient methods to store and retrieve elements out of that collection, which we will be talking about at a later point of time. Okay, most of the time in .NET, if we have to store a group of similar data types, we will be using generics, which we'll be talking about at a later session. But at this point, what you need to understand is an array is a collection of similar data types. There are advantages of using arrays which are strongly typed, and disadvantages are arrays cannot grow in size once initialized, and we have to rely on integral indexes to store or retrieve elements from the array. So that's it for today. Thank you for watching. Have a great day.